Welcome back, everybody. Here for another wonderful, beautiful Friday in Houston, Texas. Welcome back to Energy Bites. John Cao fan, the rad dad here. My wonderful co-host, Bobby Nealon.
What's up?
You doing good? And today we've got my good friend, Dingzhou. I'm gonna butcher this. Dingzhou Cao, correct? Close enough. Senior advisor in data science, right? So Ding, I've known Ding for a couple years now, but I'm really excited to have you on the show just because you've got a really cool background and story, and you've worked across a bunch of different, even before you got into energy and oil and gas, you've had a bunch of really cool experience. So thanks for coming on.
Yeah, thank you for having me. Yep.
Appreciate.
Yeah, I mean, John's told me a lot about you, and we haven't had the chance to really meet. I think we talked a little bit on LinkedIn.
I see your face a lot.
Yeah.
in the video. Yeah, and Colin. Yeah, you guys do a very good job.
Appreciate it.
Yeah,
we try. Well, so let's, the first kind of how we normally open is just kind of getting into your background. How did you initially kind of get into either energy and or tech up to kind of, current, where you're at now, right? So like growing up, were you into electronics and software and stuff? I cannot tell you the number of computers I broke growing up for one reason or another, just because I like to mess with stuff and learn and that sort of thing. So how did you kind of get into that space initially?
That's a long story. Let's say computer science, that one. So when I was in college, my major is mathematics,
Okay.
but we do have a minor in the software development. So that software engineer, we could say that one. So actually, when I was in college, one of my part-time jobs is try to assembling the machine for the liberal arts college student,
Okay.
so we can get some tips, right? So
Yeah.
let's say a female friend asked me, say, Ding, I want a computer. Can you assembling one for me? Then I will go to buy all the
hardware,
components,
yeah.
like the motherboard, like the drywall, like the CPU, and put them together and then hang over to. That's when I was in college, that 2000, around 2000.
So at least it had GUIs and stuff back then, right? It wasn't all command line.
No, it had a Windows.
Yeah,
we
like
had a Windows.NET, but it's not in China. It's not official. It's always like the fake one.
Oh, okay.
Yeah, it's
Right,
like
the
we
copy.
get it from the copy from
Yeah.
the CD. That makes sense like that. But it's working.
Yeah.
So actually, that's the college when I touched that. But my college actually we are even learn the assembling language.
Really?
So it's
Okay.
like it's
right
very
on
deep.
the hardware.
Yeah, the hardware. So actually, I'm part of the mathematics, math, and also software. That's also sometimes the hardware, like the 7 layer of the
Right.
network.
Right.
So that's why I can do what I do today.
Yeah.
So that's why I go into the tech, like let's
Yeah.
say computer science or like software. But in order to talk about how to enter the energy industry, that's an interesting story. Because when I graduate, actually I graduate as a industrial engineer. That actually is a branch of the math. It's like operation research.
Okay.
So do optimization. Yeah.
We used to make fun of the IEs in undergrad as a mechanical engineer. We called them imaginary engineers because it was all statistics and business focused stuff, which is hilarious because it's the most practical, like everyday engineering form I think that there is now that I'm out of, in the real world and stuff. Right. But it's funny too, because industrial engineering, genuinely, you can use those principles across everything.
Yeah.
right?
It's like,
Yeah.
you can find, it's optimization. It actually is
that's
optimization.
exactly what it
You
is.
had the object function, you had the constraint, and then you solve the problem. Even right now for the ML, AI stuff, it's still an optimization process.
Yeah.
Back in the thing, right? You need to solve the object function to fit that function.
Yeah.
So that's the same. So back to the story. When I graduated in 2011 as a PhD, I actually worked as a small company in Tucson, Arizona.
Mhm.
And I never think one day I'd step into energy or light oil and gas. But one day when I was in San Diego, I get a phone call from at 4 a.m. in the morning. I get a phone call from somewhere. They say it's something energy. I thought it's the DTE Energy. DTA Energy is a utility company in Detroit because I get my PhD in Detroit Wednesday.
Gotcha.
So I thought it's a DTE. So I said, yeah, good. I will check my email after later, like 6 or 7
when I
a.m.
wake up.
Yeah.
And then I said, oh, it's BP. So actually, it's BP
okay.
call from UK. And why is because like Macondo, I do statistics, I reliability. So actually my major in the IE is reliability analysis.
Gotcha.
When I was in school, I actually analyzed the unbranded tank, the tank's reliability at that time for the general dynamic link system at that time.
Okay.
So, but that's another story.
So it's like liability. Is that almost like some like actuarial type?
Yeah,
work?
like similar, like So like let's say when you buy a car, right? You had a warranty. They give you 5 years or like 10,000 miles.
Yeah.
And when you find out, it's just after 5 years
Right.
or
Yeah.
10,000 it's break.
Yeah.
Yeah, exactly. That's the statistics,
Because it
right?
was designed to do that.
That's why I did at the time. It's called Soft. It's a small company. So BP at the time become a condo. So they try to they actually create an organization called Global Well Organization. They try to improve the reliability of the well equipment or something like that.
Interesting.
So that's why they call me. And actually, I don't know when I submit the resume. I don't know when. It's just like they pull from the pool.
Yeah.
And see, this guy has the best. So that's the first call I get from them. I reply, and then after that, the hiring manager, my manager right now, still a good friend. It's just we get a 4-hour phone call. 4 hours.
Wow.
After that, they give me the offer.
Wow.
No, come to US to Houston to check what happened. So at the time, my father, it's interesting. My father reading the news about BP will pay like $18 billion to the government because Macondo. My father look at the news in China and say, "Are you sure you're going to BP? Are you going to die?" So actually, I don't know exactly what happened, and I never had a chance to come to Houston because my manager is in UK. So even I want to on-site, they know on-site. So I tried to some route channel to talk to someone in BP and say, what does it look like? Is the company still good? Should I join the company? And finally, the people is still a best friend right now, Chinese people. Chinese friends say, yeah, it's good. Everything is good. Just come. So that's why I joined BP. Yeah. And after that, it's like, it's in the oil and gas right now.
No, that's a wild story. That's I vividly remember that point in time because I was working in the field and my roommate, he was interning that summer but he would randomly just like trade stocks and stuff, and Macondo had just happened, and he was telling me, he was like, I just bought so much BP stock. Cheap. And I looked at it and I was like, why? It's bottom, like it's so low. And he was like, because BP has more money than half
they're coming
these
back.
Countries. So like, BP's too big to fail, essentially, is what he was telling me, and that the price will come back at some point. This is just an overreaction. And sure enough, I'm sure he made pretty good money. Shout out to Dennis on that one. But I thought that's hilarious. That's
a whole never waste a good crisis.
Yeah. Well, it's also good that, it's also, in my opinion, good that to know that our industry will go reach out and find, experts in those subjects when bad things do happen, because they are trying to continue.
Let me give you another story. It's the same from my manager. After he hired me, they also try to reach NASA to get a reliability guy from NASA. Because NASA, the craft, actually the spacecraft, that one is very reliable. Otherwise But you want NASA say, no, you guys not going to do that. So they decline to come to BP because they think that we are not going to do it.
Right.
Follow the same procedure. Actually, that's proof that for my 3 or 4 years in that company, I tried to do something, but actually it's too big to impact. Yeah. So.
And then you ended up you were at Ford at one point, right? You were were you not at a motor vehicle company?
Motor vehicle?
Ford Motors. Did you work?
That's when I was in a PhD.
That was before.
That's also a good story to talk about. Okay. When I was in Detroit, right? I'm in the school. So at that time, 2008, actually, 2006. Let me straight up. So the first time I come to Wayne State in Detroit, I went to the math department.
Okay.
And then after 1 year, I just feel so bored.
I don't blame you either.
Yeah. It's prove that kind of stuff. I like the application or like apply. So I like apply math.
Absolutely. Yeah.
So I try to switch from the math department to the industrial engineering department. Although it's still the same, it's just like more focused on the
right.
Trust me, I did a theoretical math bachelor's. Like all I did was proofs the whole time, and it was boring. It was terrible.
It's miserable.
So at that time, I went to the professor in the IE department. They say, I don't have the fund for you right now, but I do have a friend in Ford, the motor company. if you can get a contract position for that one, maybe you can come to me.
Yeah.
So actually, it look like this. Like Ford will had a collaboration with the IE department. I just work as a student and go to Ford for work 3 days a week and 2 days in school. So that's the plan for. So I do the interview, I do the testing, that kind of stuff. And finally, I get the offer. So I get 85,000 each year from not from me. It's go to the school.
Okay.
I get 20,000, something like that. Yeah. But it's good. Yeah. But you know that at that time, the advisor in the Ford Motor Company actually he give me a test. Well, you know how the test is like? It's like they have equation to generate x and y. Y equal to x, something like that. And then plus the noise. So it's a y equal to x, function of x plus the noise.
Okay.
And ask me to predict the y.
Okay.
So actually that's easy. I just use the supervised machine and then revolve the whole thing and perfectly. So I get the job.
That's awesome.
So actually that I went to Ford for like 3 days a week and 2 days at school.
What were you doing at Ford at that time?
That's also interesting related to the oil price.
Okay.
So I think 2007, the oil price is 149, I remember. Yeah, 149.
Yeah, it was hot.
What Ford want to do is like, they try to use the machine learning to predict the driver's behavior so that they can fine-tune the engine's parameter to save the fuel. So let's say, you either drive very widely, or you drive very mildly, or you drive in the highway, or you drive in the local, or your different environment, then they have different kind of profile for the engine.
Right.
Okay.
And different kind of profile will impact the fuel efficiency of the engine. So that is the 1 year I'm trying to work on. But it's not that easy. But we do have really cool stuff. We have Mercury. Mercury is what? What brand is it? Mercury? Mercury. Yeah, we have Mercury vehicle. Yeah. Put a lot of sensor on that, drive around Detroit, collect the data in the snow day, in the sunny day. It's fun.
Yeah.
But finally, I didn't get a good result out of it. It's too tough.
I mean, they still, to me, that's I've had a Ford for a long time, and I think that's essentially, they have the fuel gauge, and then it also estimates how much fuel you have or miles to empty,
your range and everything.
Right, your range and stuff, and all of that is coming from stuff like that. So it's fascinating to see how these topics. That's really one of the reasons we started the show is these topics that we talk about, or these problems that people are trying to solve. They're unique in certain aspects, but it's in a lot of areas they're not unique, right? Like you're trying to improve the efficiency of something that could. Every industry is trying to do that in some form or fashion. Right?
It's optimization,
exactly.
Optimization, right?
Mm-hmm.
Whatever you use optimization.
Yep.
So we tried that for 1 year, but it's not good. The result is not.
Well, that was kind of early times of like true machine learning, but even like just the hardware that you had available to even implement.
The hardware they actually take about 20-30 of the data from the engine and the brake, the steering. Right now it look like nothing, right? Because right now we have a lot of sensors, like Tesla had everything there. But back to that time,
right?
Like 2006-07 is still. That's what I'm saying. That don't just blame on the big three. We call the big three. They try to do something. It's just like
this wasn't
not there
technology
yet.
wasn't there yet.
Yeah, not there yet. They had the mindset ahead, but
Yeah. Well, I mean, I can't. Even just looking at personal vehicles, like the vehicle I had in 2007 is very different than the vehicle I have now, right? And even over the last, my wife, she got in a wreck, so we bought her new vehicle last year, and like her car is like a spaceship compared to mine, and mine's only 5 years younger, older than hers.
I tried the Saab.
Mm-hmm.
2010, the last generation of the Saab.
They don't even make Saabs anymore,
still there. Nobody makes Saab, and it's very expensive. Last time I tried to change the compressor, it cost me like 1,800.
I was gonna say it was expensive. Yeah, like no more parts. Yeah,
more expensive than a car.
Yeah.
Because when I try to change the car, they say it's $2,000.
Yeah.
And then my wife said, "Should we repair?" I said, "Yeah."
For sure. No, that's it's crazy how fast tech changes.
But the more it changes, the more it stays the same too. It's like some of the companies that I've moved on to Toyotas recently, and it's like they kind of get dinged because they stay with older technology, but it works. And
they almost have the Apple model. Right?
Yeah,
where it's like we implement it really well. Our reliability is good. Like the user experience is good every single time.
Yeah, they are still like resist to the EV, right?
Yeah, but very progressive on the hybrid side.
I think the hybrid is a good one. Yeah,
I still think that's like the best balance today, right? Like I wouldn't buy just an EV car as my primary vehicle because of the range anxiety issue. But an EV gets you all the benefits that I want locally, where I'm commuting every single day, 15 miles to and from. But then I also have the ability to drive however many hundreds of miles I want to because I can still fill it up.
Yeah.
And so but then you've got the physics of that, right? Where it's like, well, you've got all these batteries and they're super heavy and you've got the efficiency issue kind of fighting each other there. But how did you go from there and end up at Anadarko?
Yeah, that's also a very interesting story. So BP actually, the 2004-5, the oil price going down, right?
Mm-hmm.
And also, I think at that time, BP scaled back from the solar and the biofuel, something like that. They sell all the solar and wind at that time. Mm-hmm. Because before they call it back to petroleum, before they say beyond petroleum. Yeah, you guys know that story. So right now, we're not comment what they're doing right now. So at that time, we had start from 2015, 2016, we had different kind of round of layoff.
Mm-hmm.
I survived, that's fine. Because I play with the Spotfire and at that time you do in BP. Actually, that's very advanced at that time in BP because they had a lot of region and they need to know the global production. And I'm use the VB6 in the Excel to write the program to pull the data from different database and send to the Spotfire so they can view the Spotfire. I'm not sure they still use it, but after I leave BP, joined Anadarko for up to 2 years, my previous colleagues still talk about this one with me and try to get the offer from inside BP, like call it Helio offer.
The amount of Fortune 500 companies that at one point in time and probably still are running off of VBA and Excel workbooks is just unbelievable, right?
No VB6, it's VBA in the Excel.
Yep.
So at that time, several rounds of the layoff, and then I just a little get tired. But at that time, Anadarko actually create a AAET,
right? And
they try to do something, and even like inside BP at the time, BP had they call it a well advisor system, similar to what I do right now, the real time system.
Mm-hmm.
I know what they're doing, and then I want to do the same thing, but I don't get the chance. Then when I went to Anadarko, that's the one of the reason I joined Anadarko. Another is the Bellway, because the 99 is go through.
Yeah,
I live in KD.
Okay.
And then
the Woodlands.
Woodland. If that is not go through, I may not join the Anadarko. But that's one of the reasons I joined Anadarko.
That's why we moved to KD. Was 99 was open, and I was like, well, my family's in the Woodlands. That's an easy hop on 99 and go all the way up there, right? Like it makes a difference.
Yeah, that's one of the main reasons, and also actually that's a good decision because when I joined Anadarko, actually, we do a lot of good stuff in 3 or 4 years.
That's a shame Anadarko got bought by Oxy. I mean, they were doing a lot of really cool things. Like, I mean, what you were working on, but then you got, Zekta broke off from there, and like
just
Jose and Diego. Some really good.
Their approach, right? Was like, hey, we'll go, kind of pseudo crowdsource this stuff.
Yeah, they did some of that too. Yeah,
and like they did the hackathons and stuff like innovative stuff now, and that was. What, 7 years ago?
Yeah, 7 years ago.
Yeah.
And so that's, it is, they got bought because they were doing those things.
Sure.
But then, of course, as with most things, whenever smaller innovative companies get bought, they end up being forced into the old way of doing things.
Or they just say, we don't want that. I mean, like.
Right, yeah, or they just drop it all together.
Because, I had data engineer on my team from Ensign, and like they did some really cool stuff. Andrew Munoz was there. Mm-hmm. They did some really cool stuff, and they got bought by Marathon, and as far as I understand, they're like, "Oh, we don't want that stuff. We just want your acreage." It's like, but they did some really cool stuff, man. Right. Like, don't let that die on the vine. Like,
yeah.
But no, back to you. Sorry. at Anadarko, some of the cool stuff you did there.
You've got SPE papers. You've got all kinds of really, really fascinating.
Yeah,
stuff
at that time we do a lot of good stuff, and then put into production. That's more proud of because, like I told you, when your ML model run 24/7. that's the kind of feeling is good. At that time, right now it's normal. Even you use a Gmail, they had an ML model in the back thing. But at that time, especially in oil and gas, like in the drilling, that's a very old discipline. If you can have an ML model running 24/7, just classify the data. That kind of feeling is good.
Let's talk about that, because that was most of your focus. Well, it was mostly the operations side, right?
Yeah.
So drilling and completions.
Yep.
So I know you have papers on drilling models and some on the frac side as well, right?
Yep.
To talk about kind of your experience with that coming in. I'm very curious personally, because I know lots of pretty much every oil and gas company is in this spot of like, all right, we've got a bunch of data. We know that we want to try and optimize these X, Y, and Z processes because these are the most time consuming, biggest cost, et cetera, most highest risk. But a lot of them, they skip the foundational part of, you have to have good data that's structured and tagged and quality and gone through all the ETL and everything before you can even start to train a model. So I'm very curious, like your experience coming into, what you would call a traditional oil company, even though Anadarko isn't what I would call a traditional oil company. But how was that coming in? Like, did you have that kind of foundational data problem out of the gate, or were they a little bit more ahead of the curve in that? So
Yeah, but to be honest, when we are in Anadarko, the data foundation is not that good, actually.
Yeah.
So like a lot of the context data, like the metadata, like the well, BHA, June string, that kind of data, we do have, like, I think in Anadarko we use the well view or open well, I can't remember. We do have that database there, but nobody put the information there.
Right.
So that's one of the problems. And another side is the real-time side. Actually, we had a Victor mail, that. Drilling side, we always have Victor mail, although it has 30 second latency on it, but we had that one. But the data foundation for Anadarko is not that good. It's just like we try to do something. Back to that time, either you buy or build, right?
Right.
Yeah.
So at 2017, there are not so many stuff in the market. One is mobilized, that.
Yes,
they are actually the best at that time. Kova actually at that time is not that good.
Yeah.
They come from 2014 and then almost die at 2017, and then Ryan do something. I'm not sure, but right now
it wasn't interesting because we were in the kind of dabbling in that space of the completion streaming when I RDS, so we were pseudo competitors. I would never, definitely not on the software side, but on the streaming side. But we talked to Mobilize and talked to Corva and even well Data Labs.
Yeah.
Well Data Labs later is in the completion side, not in the drilling side yet.
Yeah.
But so at that time you can see that is not very good option, right? So in Anadarko actually we had enough rig to support. Like let's say if you have 5 rig, you can support.
Right.
And so that's why we decided to do it internally. And also you can see that the benefit of the internally build is like you can customize. You want something, you just do it.
Right.
And right? You don't wait for Kova to do it for you, because that will take a long time.
Yeah, because they need 4 other people to say they want it for
Yeah,
them to do it,
they are,
understandably. Like
so at that time, that's why. And also at that time, TIBCO actually come to us. They want to break the market break the ice of the market in the oil and gas. So they need a partner to work together. So here I need to appreciate my collaborator from TIBCO, Steve. Actually, he teach me a lot of stuff in the stream side, stream processing, because the TIBCO StreamBase right now I call it stream, actually used in the trading system.
Right.
The trading system is like
super fast,
millisecond latency. They use that one, is very good. So they borrow that one, come to oil and gas, work with me, and then we build that from the scratch with that one. So I learned a lot of the principle from him.
Right.
And so that's why later when I moved to Kafka, actually I just changed the tool, but the principle is still there. So that's why we come to, and then for oil and gas, you can see in the drilling side, to be honest, the data is real-time data or like context data. And also the model is there. There's not too much new thing you can do, but the most important thing is the automation.
Right.
Because right now, like let's say the Tongjian model or like the hydrogen model, if you don't make automate, the engineer need to spend 2 hours to copy paste all the input from the open well to the well plane. We call it the well plane, and click the button and runs. And nobody will do that if you don't have special need. But if you make the automate, then the people will use it every single day and it's bring value, right? It's depend. So That's why we say we need to make a lot of stuff automate. We build some ML model because like the old one, like the rule-based one is not good enough. But for other model, we just borrow, we just lease. Like I work with JuiceGAN. Right now it's part of SMP. So we lease the model from them. Just pay like 20, 30, 40, I cannot remember, $1,000 each year. Just you just
plug the model in.
Plug the model in, we just send the data, we get the result back. Okay. So I don't need to reinvent the wheel.
Right.
We just do make sure that UI is good. So I think that is the beauty right now.
Yeah.
Still ongoing.
Yeah.
But
that's I think that's great advice because I think everyone, regardless of what side of it you're on, everyone runs into that build or buy question at some point, right? Yep. And this concept of being able to build where you need to, but also license and buy where you need to. Like, it's not either or. There's going to be times where both make sense, right? Yep. Build these parts of it that don't exist that you can't buy because it doesn't exist.
And it's totally dependent on the operator too. I mean,
absolutely.
Like, we're smaller than you were at Anadarko. We're probably going to lean more buy on those things. But I mean, we like to do some stuff in-house, and there's even stuff we're talking about that 2 years ago we wouldn't have built, but now we might build now. But I mean,
resources is a big part of it.
But then, Exxon can throw 20 data scientists at a problem. I mean, like, it's just, it's a different.
Yeah, that actually, like, after I left Anadarko, actually I joined the company in Tulsa. So when my manager called me, I was in Alaska. I was in Vancouver in the conference. He called me to invite me to join the company. The first thing I asked him is, how many rigs you have?
Yeah.
Right? You need to have at least 5 rigs so you can support. Otherwise, you hire me, it's meaningless, right? So, so that's but it's come out good.
Yeah.
We built something in the completion side after 2020, that year. So it's a good one.
Yeah. So let's talk about the models side of things, because that's obviously super buzzworthy and hot topic these days. But let's talk about, because especially on the ops side, right? Because a lot of your background and focus has been on drilling and completions with optimizing those things with AI and ML, and those things traditionally are not the best from a data perspective. Again, it's not that there isn't data, it's that there is data, but it's unstructured. It's in a bunch of different places. The context exists, but it's somewhere else from the actual data.
If it's complete.
Right. And there's all these nuances and stuff. So let's talk about like the streaming side of things as far as the data ingestion piece goes, because that is the source of any kind of ML model that you're going to have. And then let's get into kind of some of the different models and techniques that y'all used and played with, and how you figured out the best ones and things like that.
So, I'd say let's chop it up there, but let's focus on, like, I guess that stream processing piece and see how it's evolved. Because like you said, you were StreamBase with TIBCO. So let's talk about, a little bit more about that, just kind of what it is. And then relative, say that sounds like you moved on to Kafka. And if you've done anything else, let's talk about those 1, 2, or 3 tools, and then like how they compare contrast. Because, as I understand, one's much more of a, drag and drop GUI, and the other one's much more, kind of code based. So let's kind of jump into that.
That's a good one. Let's talk about that one.
Yeah. Well, and like the pros and cons from someone, if whoever's watching is a data scientist at an operator and they're trying to, figure out which tool they're going to go with. Yeah. Hearing your direct feedback of like, well, this one is good for this because X, Y, and Z, but it's not that great for this because it, is batched instead of streamed or whatever.
So TIBCO StreamBase, right now they call Stream. I haven't paid attention to them for a while. I'm not sure how they evolve right now. It's actually like a Lego. Each of that is a graphic.
Yeah.
It's like the Node-RED. I'm not sure you guys play with the Node-RED. It's like a block.
Yeah.
Each block is do a different kind of stuff.
It's visual logic.
It's almost like SSIS or like a...
Yeah, you just need to put the block. The data is flow from the left to the right. You just plug in all the stuff inside and go through it.
Yeah.
They use this one in the financial market for a long time, and it's very good, but it's very expensive.
It is, yeah.
TIBCO's always
we looked at that when I was at RDS, and then we're like, no, that's not going to work for us.
The reason why they kill Anadarko one is because they cannot pay the latency.
Yeah.
Because when Anadarko worked with TIBCO, for the first 3 years, it's almost free.
Yeah, because it's a partner.
It's a partner. I use them for free. But when I left, it's not free. So they cannot afford it.
And then they're like,
so that's one of them. But another one is because I'm not sure they changed anything right now. that one is not disputable. It's not like the cloud is like, because there is a Java behind the scene, that's TIBCO StreamBase. So the guy told to me that say, Dean, we try to make the distributable, like parallel processing in the cloud, so you can scale it. But they say scale. They cannot do that. I'm not sure they can do it right now, but they are very useful and very easy to pick up. And they have a lot of the block you can just plug in your model, so you can see that data coming. You put a box here. What kind of equation here?
Right.
It's like the water, right? Water flow here. You put a red, and it's coming in red here. So that actually that's actually the concept. But the Kafka is different. Kafka is like a pond. Mm-hmm. It's like a big pond or lake. You put all the data there. You have small app to get the data out and processing and put back in a real time. So this two is the two different concept of the software.
And it's because handling sharding and then writing to distributing out, it can kind of fan out. To different sources.
So the StreamBase is left to right. It's the sequence processing.
Sequential.
It's sequential processing. But you can have different kind of line to do that.
Yeah.
But the Kafka is a different one. Kafka is like a big lake.
Yeah.
All the water there, data there. You just get out, process, come back, and next one just get back based on the topic. So that actually is the big difference.
Yeah.
But but also, Kafka is much more code based. Like originally it was Java, and then they built like KSQL, and they built, Confluent obviously has like the Kafka Connect, where it makes it a little easier. You can define things on either side, and it'll kind of run those. But there's a lot more overhead, and even just like deploying Kafka, like you said, StreamBase maybe doesn't distributely or horizontally scale, and Kafka does, but it takes a lot more how to deploy Kafka.
Yeah. But the Kafka right now, you don't need to manage your own one. Like when I was in the private company, we work together, right? We try to put the Kafka in the field.
Yeah.
And that's cool, right? But it's a little heavy. Like we talked about it's not designed for the field because it's not designed for the data center. It's not for the edge. So, but I'm not sure right now how it's doing.
Yeah.
But like you say, the deployment is a little bit hassy, but right now it's all cloud. You just use the conference. You never had any issue.
Right.
They give you the connect stream, like URL plus the port. That's it, right? You just talk to it to get back. But StreamBase, you need to install that one in your local machine or in your VM or like Kubernetes, I don't know. And then you run it there and you connect to it and do all the stuff and deploy it. It's a little different. StreamBase is the old days of the software development.
Yeah.
And the Kafka actually is the modern life. That's what I can say.
Yeah. And they've got the managed version.
I think it's worth talking about too, and I'm not trying to be a TIBCO salesman, but is that StreamBase connects right to Spotfire too. So then you have end users, your drilling engineers or completion engineers that are familiar with doing stuff in Spotfire. That can be a source into Spotfire, and they can do.
That's one point I want to mention. Back to 2017, when we worked with the TIBCO, actually at that time the sales lady is Kim, and I cannot remember her full name. Right now, she is with Microsoft right now. At that time, we give them the suggestions like you need to hook up the StreamBase with the Spotfire, and let the Spotfire as the real-time visualization.
Visual,
like the tick, tick, tick. You can see the clock. But I don't think right now they may happen yet. No,
I think they've got it now.
I'm not sure.
I know.
But at that time, we give them the suggestion. Say we want that at that. You will have a lot of market because like oil and gas guy always use
they want to see
the Spotfire, right? It's easy, and if you can get the real-time data flag, like a Grafana, right? It's as useful as a Grafana. That everybody will use it. So so that actually is if they can integrate like that way.
I think they got it recently. I know previous group you were working with, I think they had the connection and it was connected to the StreamBase. I know it is a source to Spotfire now.
But I'm not sure the Spotfire can
the real time part.
Actually show the plots.
Show that like every single second you see that.
We saw someone do it, but again, it wasn't native. It was because the text area in Spotfire you can use as a web page. So they installed.
Oh yeah, that one.
So they installed, and I don't know if they're using like
I use a web player,
like Plotly or something like that.
Web player a lot, yeah.
Well, but the text area you could install like Plotly or pull the CDN.
Oh, okay.
And then you can like visualize it, but you're using JavaScript behind the scenes to connect to that, not truly the native.
It's a workaround.
Oh, it's a workaround. Okay. Yeah, but even right now I use Spotfire. I like it because it can be million of low.
It's such a great visualization tool if you have large data sets.
Yeah,
that you want to visualize.
I tell you, right now we had a real-time model 24/7. So what we do in the morning, we will view the past 24-hour data. pass for 24 hours, how many data points you see? Each hour is 3,600 times 24.
86,400.
And times the 25 ring.
Yeah.
It's a
times
bunch of
yeah.
data. And then we view that and try to see what the model look like. Is it a long prediction? Then we collect that one. So that's the Spotfire. We use a Spot every day. Spotfire every day.
Yeah.
Yeah, no, that's one of the consistent points I feel like across the show is that if you can make it easier to use whatever it may be in the place that the end user is comfortable,
and meet them
whether
in the
that be Excel, Google Sheets, or Spotfire,
Power
or
BI,
whatever,
whatever,
whatever tool they're comfortable with is normally the best way
you're gonna get buy-in.
Yeah, get buy-in. That's the way I like recently, maybe out of topic for this question, but right now we had a deal stealing team. They want to they use a star stealing. You guys don't know.
Yeah,
right?
we had Igor on.
Yeah, so they rely on the rig to send them the data and plug because they need to send out the report every 3 days, 3 times a day.
Right.
But they rely on the rig to send them the slide data or other data. Right now, because my system, we just push the data to the star steering, and they just hit the button and they get all the data. Before, they never know that that's easy, and also our quality of the data is good because we had the ML slide model actually running very accurate, like 95 or 96, 97, something like that. When they get the data from the rig, they say, okay, 2 o'clock to 2:05 is the slide.
Right.
Yeah.
Right.
2:06 to 2:10 is the next slide. But actually, it's no. It's like maybe 2:03 to 2:05 is the slide.
Yeah. It's the difference in a human writing it down in a spreadsheet, which is probably where it's coming from, because that's how all the field stuff happens, right?
And we get to every single level. So single second level. So this second is a slide or not? We classify. So that's it. Okay, let's go back to the Spotfire, not the Spotfire, the StreamBase and the Kafka.
Yeah.
So another thing is like, I think it's like when I go out of Anadarko, I see what happened to the system we build. I feel that we need to get that kind of technology, which is open source, but you still had a managed service.
Right. You had support.
Yeah.
That's why Kafka come into the spot.
Yeah.
Greatly, because like you never know next time who come in to get the current company, and they're open. It's similar to like the cloud, the same thing. Right now, a lot of people like to write the application into one cloud.
Yeah,
like either AWS.
But then you're locked in.
They log in. That's what happened.
You make it portable. You can move it around.
Yeah, in Anadarko, we use the Google Cloud at that time, but when Oxy coming, it's Azure.
Yeah.
So if you do anything, use the GCP. You need to redo the whole thing in the Azure. So that is crazy. So that's why right now I try to avoid this kind of use the native service in the cloud, a single cloud. But if like Kafka,
you can run
AWS
if you can containerize it,
yeah,
or whatever.
Even different cloud service they had a Kafka managed service. Like AWS has, Azure has, like Google has, and also Confluent has. So that's another because of vendor lock. We don't want to be locked by the vendor.
TIBCO, you're tied to them because that doesn't go anywhere else, right? You know, like at least maybe like a Python script I wrote in a Google function, I can maybe tweak it a little bit relatively quickly. But like if it's StreamBase, you just got to refactor everything. You know, and
it's painful.
Yeah,
it's painful. So
that's what they're banking on, though, right? Like that's a lot of their business model.
Yeah, that's sticky because it's working.
Yeah.
And like,
well, that's why
it's going to be $1 million to cut off it anyway. So that's 3-4 years of license fees.
Like Pi, OSA Pi, right? Right now, a lot of people had an issue with that one.
Yeah.
The Aviva tried to phase out the Pi. I move all the customer to Aviva. Yeah, but people don't want to use Aviva because it's more expensive. But you rely on the Pi, which is written in VB6.
And everyone uses Pi too. Like it's very similar to Spotfire, right? Where you've got a license on pretty much everybody's.
The problem is the Spotfire keep update with the technology.
Yeah, that's true.
Yeah.
I don't want to say the name.
No, I mean, all the users of it they know exactly what you're talking about.
Yeah.
It's crazy. They don't keep update. It's still a VB6 in the back end. And never invest their tiny on that one. And they just try to push all the Pi customer to the Aviva.
Yeah.
Now that's Yeah, no, I mean, this is exactly why we have this show, because a lot of people, you don't know what you don't know until you go
look
through
down.
that.
You get
and
into
you're like,
it,
well,
you feel the
shit,
pain, right?
Yeah.
it's going to be $1 million for us to migrate this, or we just live with it. Right.
Yeah.
And so, no, that's definitely, if y'all haven't, if whoever's out there that's in the data ingestion side, if you haven't looked at Kafka and Confluent, it's a very, very useful tool for that real time.
And we use
streaming.
it every single day, right? Uber's
Yep.
bang is the
Yeah.
Kafka. When you place the order for a ride, that's the Kafka. Send the message to some place and do the
Yeah.
so-
Well, and that's the other thing too, is as you're evaluating those solutions, look at who else is using them, because Uber has a much more difficult use case than we do in oil
Yeah.
and gas, no matter how you
And
wanna
Uber
slice
has
that.
tons of Silicon Valley software engineers that
Mhm.
focus on that, and they're writing open source software, and like that's why things come out of those companies that other
Right.
people use because they built in-house solutions because they have the team to do it.
Mhm.
All right, so let's move downstream a little bit from there. So it's into Kafka. Let's say now you've moved on to Kafka. Where are you landing the data? Does it go into a database? Does it go into a
You're
data
in
lake?
always
Like,
go to Snowflake.
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 Right?
Okay, y'all.
Yeah, we have really good enterprise Snowflake.
Okay.
In fact, all my data is stopped in the Snowflake. Whoever want to use it, they just go there and get
Okay,
it.
yeah,
We
that's
have-
what we use as well. So
Yeah, and we used Mongo before. We may still need to use Mongo one day because Mongo is a non-SQL, so you don't need to
Right.
define the table.
yeah, but you can drop your JSON blob into a staging of Snowflake, and then they have the parsing. They
Yeah,
can do
maybe
JSON,
that
because you can do JSON parsing in Snowflake.
Yeah, because right now that's back to the VictorMail. It's more detail. Like VictorMail, you have 400 or 500 columns,
Mhm.
right? But we only need
Right.
50 of them. For
Yeah.
the remaining 450, some of them have data, some doesn't have the data.
Right.
That we call the dynamical column. Right now, we try to get that one. If they had the data, we still want to get and see
Yeah.
whether it's useful in the future. But we cannot build
Right.
a table for that because each read, the name is different, something like that. So that's why maybe one day we need to use the Mongo, or like you say, the block and passing the
Yeah.
Snowflake to that one. Yeah. Yeah.
Okay, so it's in there, and then so now let's talk about what you've done in the past and what you're doing now. So we're doing training real time models, right? Or
Mhm.
so do y'all train the model and you just let it run, and are you just passing in and getting the outputs, or are you also training it in real time? And is it once it gets to a certain confidence level, are you deploying a new model, or are you just, is it more kind of a manual process for you?
Yeah, that would be an interesting topic to talk. Right. So right now for the Julian side, we only have one ML model running 24/7 in production for
Okay.
almost 2 years. That's the ML slide, right? The slide model. We built that in Anadarko, and I rebuilt the whole thing, but the different architecture. Because Anadarko, we use a convolution neural network.
Mhm.
Right now, we use
Okay.
a mini rocket. That's another model. But my goal is like I always try to see what is available in the open source community and try that one.
100%.
Like let's say Meta had a new model coming out,
Yeah.
maybe can be used by my use case. I will give a try, whether it's good or not, and continue. So that is one side. We try to see whether we can use a different kind of new model to improve. Another side is like you say, we don't train the model in real time.
Okay.
So the model will train offline and put in real time inference. But we retrain the model whenever we feel that is needed to. For example, let's say
there's a unique data
Yeah,
set.
like,
or a
let's say
unique point.
right now we have 20 rig. Tomorrow we add 2 rig.
Yeah.
The 2 rig, we never see, the model never see the data for the 2 rig before. And
Sure.
also maybe the location of the well is never had the training data before.
Yeah.
Right.
So we need to monitor that 2 rig and see how good are they. A lot of time we use our eyes. Sorry,
Sure.
we don't have good stuff because they don't have ground truth, right? When the real-time data coming, you never know it's a slide rotate until you use your eye to see, or you use the model to classify.
Sure.
So that we don't have an automatic metrics. We use the eye, like me or one of my teammates. We'll view the past 24 hours, use the Spotfire,
Yeah.
and then
Well, we have a funny story about that. When Bobby and I were working together, he was messing around with building some frac models to identify the different, like,
To
even
classify the
just
different parts of the frac
stages
stage,
initially,
like
right?
stage.
build up, breakdown, year,
And all of that.
ISIP.
that's very useful, right?
Yeah.
Well, because we were trying to get, because like it was either that or we were gonna have to have like our account manager or someone looking at it and brushing and marking, so we were
Manually
trying to like
tagging.
classify that, so that because a lot of people then wanted to be able to align normalize wells to breakdown or normalize them to frac start or to ISIP, but you have to have that classification first.
All the metrics that you want typically on at least on the frac side are very easy to back out when you know the start and stop, right? But the start and stop, or which part of the start and stop you're in, are you in the pad or the ball seating or breakdown or wherever you're at, is important. And so we were having these conversations, and I asked him, I was like, it's almost like we need a computer vision model, because like visualizing that data is so much easier to say,
I can look
at
at
least
it
for a human, to say, this is where this happened, this is where this happened, and this is where it started and stopped and all of that stuff. And so like Bobby just built a little,
you can build an R with like Plotly, and it was just
you would brush, it would pull up the data set and you would brush it, and then you would tag it. And it would get saved back to the data set. And I was like, that's a brilliant way of doing this.
That's labeling, right? That's labeling.
Yeah.
We call labeling. Yeah, that's what we did.
But you have to do that up front. I mean, someone's got to train it. I mean, so whatever it was trained off of my eye, which I generally knew. But then you bring in bias too, right? Because you should probably have a handful of people doing it. That way you get a few different experts' opinions on it. But
people don't think, like, people think that it's like, oh, I've got this data set and then I can throw an algorithm at it and then it spits out all the good shit, right?
Yeah.
Like, it's like, no, you manually have to go through and tag thousands of stages, right? Or if you're good, like, shout out to Well Data Labs, right? Like, they built their interface so that the user is tagging these things, and then it's getting stored, and then you get enough users doing that. Now you have federated learning feeding your model constantly, right? Doing it, I think more companies in the energy space on the software side specifically need to understand like the processes that their users are doing, and how and if there's ways to use that to build and train models, because that's happening literally every day. So instead of you feeling this overwhelming, like, where do we start? We've got 10 years of data and thousands of data sets. Like, no, just start now.
Small piece.
Small, let the users, like, as much that you can do where it's being crowdsourced from the community and the users that are using your stuff every day, the better, because they're the ones who are they're the SMEs on it to begin with, right? Like,
well, and you talked about like, hunting for, and again, technology changes so much, because now like neural networks are like old news almost, right? But like at the time, I mean, I ended up searching around trying to find and I found a good neural network for classification that some PhDs had written. So I was like, let's try it out. And, and then had to work on the kind of the overlaps and finding the right distances. But like, they were doing basically what I was doing for a different application. More, I think, medical or whatever it was. But then it was like, well, they're just looking at, different streams and like training it. And like, it was a recurring neural network, and it, worked pretty dang well. I didn't say long enough to see it through. But
so what's some advice, both, things that you had to learn the hard way and things that you found out the easy way, but what's kind of some advice that you have for people that, are data scientists in these different companies and stuff, trying to, start using ML? Like, what are some of your big, pain points that you ran into that, now you wouldn't run into, but you only know that because you experienced it firsthand, right? Like,
my first advice is always the use case. Focus on the use case. Don't care about the fancy model. So like right now, a lot of people think that the model is more important, but actually not. Like right now, they had always had two opinion. One is the model central or like data central. That's right now. Model, that means you always try to build a SOTA. That means the state of the art model. This is always good. Use the same data set and build a good model. But on the other side, like, they always try to get the best data and use, because a lot of model is not that huge different.
Right.
So that's what I want to tell the young guy, if they want to come in and say, whenever you try to do something in VisitMail, you need to focus on your use case. Use case. Like when you buy a house, it's always location, right? So here is a use case. When you get a good use case, either you use a very dumb way to make it happen, or use a very fancy way to make it happen. Doesn't matter. Either like when I was in BP, I used the VBA and Excel to make it working, but I made it working.
Like solve someone's problem. If you solve their problem, like,
and I get what we call survive in several rounds of the layoff because that stuff.
Right.
Although I leave, but but it's not like technology sometimes is good, but you cannot just use the hammer and try to find the nail.
Yeah.
You get the nail and then you use different kind of
use
stuff
the right tool for the job.
To the right tool for the job. Even it's a really dumb one. Even you are a PhD, doesn't mean that you don't play with the Spotfire or like the VBA, right?
Yeah.
So
no,
that's my suggestion. And that is very important.
Yeah. I mean, I was talking to Colin out there about it, like when a user uses a website, they couldn't care less whether it's Ruby or Python or Java behind the scenes or using React or Angular. Like when I click the button, does it work? Does it spin up fast? Like, so, I mean, use whatever tool that works and gets it done. But the end users, we live in this technology world where we know all these different technologies and think, oh, we got to use it. 90% of the people out in the world don't care. They couldn't care less.
They don't.
What you're using. They just want it to work and to solve their problem.
Well, and I think the other thing that people run into when they're chasing new technology is that, like, we were having this conversation the other day, but like vector databases, right? There's a group here that I've been to a couple of their meetups. It's a Houston AI group or whatever, but a lot of the conversations are like, well, here's a list of a dozen vector databases, right? Like, which one should I use? Who's gonna? And it, like, when you're that early, when you're almost like in that bleeding edge space, you don't know who the Googles and Microsofts are gonna be. And so if you choose one and you go build your entire stack off of it and it doesn't survive, then you're screwed anyway. So understand the new things that are happening and what's happening there, but don't immediately run to them as the first thing you're going to use, because guess what? There might be something that has existed for 20 years that has full support, all the documentation in the world, and it's super easy to use, but it's not the sexy
name.
Right.
Name.
Exactly.
A lot of times it's just the sexy name, right?
Yeah.
Like the day I reading a news, MIT professor just changed the name of his class from linear algebra to AI foundation. And the class is just like
got huge.
Huge. So the name is just like.
Well, I guess I took AI foundations back in 2008.
No,
I guess.
good. It looked good in the transcript, right?
No, Colin has the same story. He said there was, I don't remember what company it was, but they were at doing a talk at a university, a presentation for the students, and it was something about using. It was very technical, the original time that they presented it, and then the next one was like leveraging AI for this, and it was like the first time they did it, there were like 2 students, because it was talking about mathematical application of et cetera, as we do in the technical community. We're very technical with the names normally, but then the second time around, the marketing department had gotten a hold of it and they molded it into this, whatever with AI, and the class, it was full. Right. Like, and branding is a huge and a very real, marketing and branding is a very real thing. But when it comes to dev and stuff, like, just because it's old doesn't mean you shouldn't use it, or that it's bad, or that it's not, like, there's a lot of value that it brings. And it's funny because when I was younger, I feel like I would be slapping myself my current self for saying that, because I love the bleeding edge stuff. But it's when it comes to application and real world stuff, it's a lot better to have.
Well, you need things that are hardened. I mean, there's a reason Java is still running a lot of things. It's tried and true. It works. C Sharp. I mean, like, Python's fun. JavaScript can be a mess. It's like
you let someone else learn the lessons, right? So like the scalability, you have scalability, you have security, you have all of these things that you don't know about when you're testing models on your laptop versus when you deploy it full scale across an organization.
Well, and then there are pitfalls with open source sometimes too. I mean, like, wasn't there? I mean, it was probably 5-6 years ago. They found a problem in NumPy and a lot of people had built their statistical models for their dissertations and or published papers based off of that. And they had to walk some of it back because the NumPy, model wasn't actually calculating purpose. So, I mean, there is, pluses and minuses. You got to know the tools, or, some things that you want to believe. I mean, I guess it comes down to the whole licensing versus, having something, do I use SAS or do I use R? I mean, I don't want to use SAS ever, but, the liability's on SAS if it goes wrong. Like, but, if I take an R model that someone wrote and I don't validate that it's actually doing what I think it's doing.
But is backed by IBM, right?
No, I don't believe so. I mean, Deposit, they rebranded Deposit. There's RStudio. But,
they rebranded?
Well, RStudio rebranded Deposit so that they're more like, because I think they do some Python now and they support Julia and all that.
Oh, I see.
But it's still like the IDE, the open source one's called RStudio still. Okay. But no, yeah, I mean, I think there's still R is still open source. It's not, and actually Microsoft. It's funny to talk about Spotfire. Microsoft did that whole Microsoft Revolution Analytics, and they had their own repository. There's CRAN is the main repository, and then they did like MRAN or whatever. So a couple months ago, one of my R data functions stopped working because for some of the users, because they had got the newest version. So TIBCO was using Microsoft's repository to load it. So it was loading the newest version of dplyr in, whereas everything I had written was based off of version 0.9 or whatever that TIBCO had previously. So they had to write a hotfix to repoint it to CRAN because Microsoft shut down that repository once they discontinued supporting it. And then when Tear pulled it for all the new users, they were getting the most recent version because I guess it would default to the major CRAN. So it was interesting.
Benefits of containers. Right?
Yeah.
Yes. No, I mean, I run into that all the time. That's half the reason I in my opinion, I don't code more, is because I'll go try and, install a new package or whatever. And it's oh, well, this package is out of date, or this one is too new and it isn't supported by our current, you're like, oh,
dude, that's another one I want to mention is right now we have so many packages.
Yeah.
And sometimes it's old, sometimes new, like the Python. It's better than Python. It's if you don't specify the exact version, but you always run into issue.
Yeah, but Python, at least, I mean, in my experience between Python and R, I used to hate Python because I could never get started, and I had Conda and I had this, and had installed 5 different versions. I didn't know how to make it work, but now that I understand virtual environments but that you can define the requirements.txt file, and you can say, I want your requests equals the version, whatever, and you can lock it in for that environment. I mean, that much better environmental control, whereas I think R is trying to get there with some RENV, but it's not nearly as good. Yet, right. But R, I mean, I can install R in RStudio and get someone up and running that. So there's pluses and minuses there. Yeah. And I did want to ask, I mean, and maybe you probably answered both, but I mean, what have you used? Is it mainly, has it been R, has it been Python, or are you using that now? Or
we are mainly, okay, let me put it this way. The whole ecosystem in the tooling side, we have different kind of language. It's because in the company 50 years old, you had different kind of system.
Sure.
You need we had C# to get the data from some place, and we had the Node-RED to get the data from other place, and we had the Java as the main for the Kafka, because Java is a Kafka. Yeah. Kafka stream or Kafka consumer and producer is a Kafka, is a Java. And also the model, all our model is in Python.
Okay.
We write either the ML model. ML model actually is the file, right? You just embed the file and then you build a wrapper to get inference, that kind of stuff. And also engineering model, the token engineering model is the bundle of equation. You just write in the Python.
Sure.
And pack as the API. Right now we pack everything as an API and run as an app. So everything is containerized. Even all our other app, like the inference app, or the Sing app. What is the Sing app? That means we get the data from the model. We need to write back to Kafka, or we write back to Snowflake.
Yeah.
That we call Sing app. So we have more than 40, 50 apps right now, include the model. So that's the people come to me and say, Ding, how do you do ML op? I say, I don't really do ML op because my whole ecosystem is follow the software development cycle.
Yeah.
Because all my app is software. It's not just a model. Model is just a small piece, especially ML model.
Yeah, you have to write a Flask app or a Fast API or something
I need to manage them in the same way. Otherwise, I just specify something for the ML. Later, it's just harder for me to manage it. Similar to you had a free, American airline. You have half the aircraft is Boeing, half the aircraft is Airbus. Right. It's harder for you to maintain that kind of stuff, right?
Sure.
So, so that right now we have different kind of language. Whatever old system we need to talk to, use what kind of language?
Yeah.
We will use that language. So
of course, yeah. I mean, again, you've got all different kinds, and again, probably C# and Java probably been the most traditional, in the past, as far as software engineering and data integration type stuff. But I mean, I was thinking more on the model side, so it sounds like more Python than R.
Model, like I said, is more packaged. You don't need to write, if you want to write a model, it's a Java, you need to write from scratch for some of the basic calculation. But in the Python, you just get the package and run them, right? But that's another story I want to share. Is 24 years ago when I first played with the ML, the back propagation algorithm.
Yep.
I write in the C by myself. And
And that was C, not even C++.
No,
C?
it's C.
So not even object oriented.
And you can see that how sometimes I feel that I appreciate so many packages.
Oh yeah.
But sometimes too many packages wasn't issue. But when you look back 20 years ago, you need to write the whole equation. Yeah, because I get
and
the
manage
paper.
the memory and
I get the paper, the equation. I need to convert this equation into
and had to compile
them and then run that. And also at that time we had like the parameter is like several thousand. I learned to change the neural network is about 8 hours, something like that.
Yeah.
And also we had a supervised machine. At that time we run the sample we had is 200 sample. But look at here right now, like what the ChatGPT, how many parameters?
Oh gosh.
Hundreds of thousands to billions now.
Yeah.
So you can see how the hardware actually the hardware enable a lot of stuff.
Yeah. Hardware and memory. I mean, like
memory, the hardware.
Because I mean, I talk to people. I mean, like you brought up Snowflake. Snowflake is $23 a month per compressed terabyte. I mean, I remember talking to like Jeremy Funk and a couple other people I know that were doing software and hardware sales like 20 years ago. It was like hundreds of thousands, almost millions of dollars for terabytes of storage. Like,
but like I told you when I was in college, I assembled in the computer for my classmate. Yeah. At that time was our standard configuration. 120 megabit memory, 30 gigabit hard drive.
Yeah.
I think the CPU is 800 or 1G.
Well, not multi-threaded.
What was it? What was it? Was it Bill Gates? Isn't he famous for saying something like you'll never need more than 256 megabytes or something like that?
It was literally it was shout out to my high school computer science teacher. She had that quote on her wall in our computer science lab, and I think it was Gates, but it was like, user will never need more than 256 kilobytes of RAM.
But at that time we run the Windows.
Like, you've obviously never seen Slack. Yeah.
But at that time we run the Windows very smoothly.
Right.
Yeah.
Right, like Windows 8 or Windows Net, NT, something like that, or Windows 2000. Yeah. It's running smoothly. But right now, I look at my memory right now. It's like my desktop is 32 gigabit.
Oh yeah.
You see.
Well, I mean,
but think about
this is more powerful than any computer I had.
But even
think
about in-memory processing now, I mean, that's a huge deal. Like if you can get data in memory, like you can process it much faster than like off the hard drive now and everything, right? And now you also have solid state versus spinning disks, which is a better deal. But like if I can throw it into RAM, I can process it really quick. But yeah, I mean, like definitely like the hardware improvements have enabled so much, and again. What was big data when I even got into the industry, and big data is not even like a thing anymore because it's not big. I mean, like
it's not big.
Seismic would be the only one that might qualify for that.
But not even for us. I mean, like, I just don't even think big data is a thing anymore. Like, people don't even say big data anymore.
Yeah,
like,
that's very true. There's like because there's always data.
There's basically infinite compute. Right. Knock on wood. I mean, like
right now when you look at NVIDIA's new GPU is like longer than a truck, right? I think like
really? Is it that big?
Wow.
Oh, it's big. It's like to here is that high. It's like I cannot remember the model name. But it's very big from here to here because like for the GPU, the most important is the GPU communication to GPU. So like you send data from this to that one. So you need a bandwidth very big. So that's why that's the key. And also another is like NVIDIA already had a CUDA.
Right.
It's an ecosystem like the Windows we have right now. So if you want to break into that one and get another empire, that's difficult. Although the technology is not there, but people get used to load the library. Like if you say the library, like the package is already there. You can spin up in like 1 hour. But if you get a new one for AMD or something like that, you take a lot of time to spin.
Speaking of CUDA, I mean, you shared it with me and I had seen it through another one. But did you see like the news this past week where like you just feed like there's the package, it's a CUDA DF package in Python and it'll speed up your pandas by like 150 times.
Wow, I didn't really.
Yeah, we'll share it with you. Like it's a simple, like you can keep your pandas code. You just define it at the top of your Python script, and it will accelerate up to 150 times your pandas code.
Yeah,
using if you have access to the GPU, like through
I think we're gonna see a lot of really interesting shit around like the hardware hardware acceleration is what it's called, right? But this idea of hardware continuing to accelerate software as well with all the ML stuff, because it's all, most of it at least, seems to be GPU based moving forward. And so those are very expensive and they're they're not cheap, they're not easy to maintain and stuff, and so that's it's gonna be interesting to see how like
John, we are work together on that one like 2 years ago or 3 years ago when we don't have a Starlink. What we use in the field in the fragment is LTE, right? LTE or like satellite.
Yeah.
Right now the Starlink coming,
Starlink,
200 or 300 up and down. It's no issue right now. It's nobody complain about that.
Yeah.
Because that day when I talked to Neighbor and Kowa, they work with they collaborate. I asked them how they collaborate. They say that Kowa will calculate the roadmap for the new well to drill and send to the rig so that the checkpoint.
Right.
So that the rig can follow and do that. But imagine without the Starlink, how can you do that? Because like everything, the Kowa stuff is in the cloud, and you send that.
Because the satellite stuff we were using 5-6 years ago was slow, super expensive. I mean, like
that's John and me work together. At that time with the high cell, we try to make it more stable, and then use the LTE like the Paul. I think Paul, the founder of the high cell, at that time tried to put a modem there, so in the high cell. So, but right now it's not an issue anymore. You can see how the technology. Elon Musk, I don't have too much feeling on him, but sometimes he did a good job. So Starlink is what solve all the oil field problem right now.
Yeah, no, I mean that has historically been one of the biggest issues is how do you get the data from the field to a bigger computer processor to the cloud so it can do whatever it needs and then send it back. And I think that's a huge development moving forward. Is the
so right now nobody complain about the internet right now.
No, it's funny. It's crazy how that's changed.
You worked with RDS before, right?
Even before that, when I was in the field, right? Like everyone, the engineers and stuff and supervisors would have hotspots, but those would be capped at, a gig or whatever it was back then because you paid by the megabyte. And then you'd get, the guys in the field would be in their van watching porn on the cellular signal, which is the same one that you're supposed to be pushing your reports and stuff. We weren't even streaming anything. We were just pushing reports and like files, but even those would get bogged down because they'd use all the bandwidth watching TV or streaming, trying to stream stuff.
Yeah, I remember the guy just called say, I just watching a movie. I long out.
Like, you can't do that, man.
It's funny. I mean, kind of brought up, it kind of clicked for me a little bit. There are some parallels that even say, we knew shale, there oil existed in the shale for it, but it wasn't economically viable or technologically viable. And then you see some of these parallels, like, talking to you about what you were doing 20 years ago, or you talked to Talal and he was doing computer vision for his, master's thesis back 25 years ago. But like, again, you just didn't have the hardware and stuff to really do it or productionize it. But like all of a sudden, once it catches up, like, these are not new concepts.
Yeah.
It's just we can do them or apply them at scale or affordably, and it's pretty interesting.
It is. It's very true. It's new and sexy to the average person, but for the OGs, they like, I've been working on this for 20, 30 years now. It's but the hardware definitely enables the idea. Like, to your point, those ideas aren't new at all.
Yeah,
the idea of ML isn't new at all, right? It goes back decades, but the actual, commercial implementation of them gets enabled by the technology side.
Yeah, like 2 years ago, you may hear about me about all edge computing. But these 2 years, I don't say that.
Yeah.
Why doesn't need it? Because we had Starlink. Why? Sometimes we still need some of the model, but for model, you just put in the cloud and just push it because Starlink is really stable and very fast.
Yeah. That's talk about Snowflake. I mean, if I want something to run faster, I click a button and within a second, and now I've got twice the compute.
Right.
Yeah.
Like, and it runs twice as fast. Like, it's just
What I want to ask you this because we gotta be wrapping up here. But how do you see automation moving forward with? Because to me, the first step, we're focused on data, we're focusing on ML. The one of the big kind of visionary things with ML is automating processes, things that happen in the field, whether that be just on a regular rod pump well, shutting off the motor or closing a valve or whatever, all the way to the dream of completely automated drilling rigs and frac sites and all of these things where there's all this risk associated with humans being out there. How can we eliminate as many humans as possible and the human error element? How far away do you think we are from some of that on the ops side, at least? because like to me, when I got into the edge side, that was like the immediate click for me was, oh, if we have this computer here, then that enables us the ability to potentially automate these processes, because you take the internet connection liability out of the equation, right? Like if that goes down, you still have the ability for the entire process system to operate because the computer is local. It's not, and the model is local. It's not up in the cloud. But just in the last 2 years with Starlink and things like that, like how do you, has that changed your perspective on the automation side of things at all, as far as like we might actually be able to run some of these things in the cloud, or do you think there's always going to have to be that level of redundancy of having local compute?
From my perspective, it's like we always need to have a local redundancy.
Yeah.
The another one is like from the technology perspective, I don't see any issue.
Yeah.
Because the automation, I don't say that you auto drill the well, like just like blind drill the well. That's the whole story. But for other like pipe handling, like that kind of risk stuff, that kind of stuff, I think from a technology perspective, we can do it. It just depends on several factors. One is like the culture. We have a lot of people working in the field like 30 years. They are not going to change the mind, right? Like the second one is like how much money we're going to put into it.
Yeah.
That's like my VP when I was in the private company in Tulsa. My VP of the drilling completion, he said, "Ding, right now the vehicle can auto drive in the street. Why cannot have auto drilling rig?" I said, "Yeah, I cannot say that the technology is there already, but with the investor, we put in the money into the drilling completion of oil and gas, then we never go to hell. Imagine when the car auto driving in the street, how many money we put each year globally, right? $billions, a lot of stuff doing, a lot of people doing.
They custom developed the whole edge GPU device for the Teslas.
But for oil and gas, everybody think we are the sunset industry. Who going to put the money? And if you no money, I don't say the technology cannot be breakthrough, but you need to have the investment there.
Yeah.
I don't think it will going to be happen one day, except that we see the drilling technology can use to drill another kind of mine, like the different kind of metal, something like that.
I think people want to rush to it too. Like you got to take baby steps. Like, can we remove half the people off the rig?
Yeah.
And I don't mean that from like I want to replace people's jobs. Certainly you can save on G&A costs and stuff from that standpoint, but there's also just inherent risk of life limb, safety side of it. There's large implications, but I think there's got to be that those baby steps of like just the augmented intelligence where like these are informing them to do things better.
Yeah, augmented turns into automation.
Yeah,
yeah. But I think that as the time go by, we can see that the people in the rig or in the field will get small and less and less because we automate a lot of stuff, not just from the data perspective, but also from the operation perspective. Like the neighbor's new rig, like the pipe handling. You know that Neighbor and ExxonMobil, they had the new rig do the pipe handling in the Permian right now. Because the first time when it come out, a lot of people come to me and say, "Oh yeah, Neighbor and ExxonMobil had automated drilling rig." And when we say, "Oh no, that's just a handling of the pipe."
Right. Yeah.
Right. That's everywhere. Like Tesla's Gigafactory, they use the robot to do the handling. Kind of stuff. It's nothing new, right?
Yeah. We've been building cars with robots for years. Yeah.
So, but I consider all these kind of like this kind of stuff will gradually coming, but not going to be happen one day.
Yeah. So it's got to be like
take time.
10
or
years plus or minus.
Yeah.
10 plus years.
Yeah. No, I think the big thing there is that the perspective of the companies need to be, this is a long-term investment. This is a long-term thing. And we don't need to come in and say, how do we replace the entire rig today? It's how do we inform them to make better decisions so that it's more efficient. We can drill faster, we can drill cheaper, we can get more oil at like whatever that may be. But then over time, you get those small wins and they compound into a solution at some point, right?
Yeah, that's actually exactly like 10 years ago, how many rig we have.
Right.
And how many rig we have now. And what's the production 10 years ago? And let's say we just use the US
efficiency
and Permian. So you can see that the technology actually improved in the past 10 years dramatically in oil and gas, in the DNC. You can see that, right?
Yeah, you can't use rig count anymore as a direct factor of production because of how efficient.
Yeah, all of it. Just being able to drill all the step outs and everything from one location, and then like even zipper fracking, and simul-frac now and all this stuff. It's just.
But I see that the automation will be still ongoing, no matter like the data one or like the operation or like the execution. It will gradually move on, and then we see less people in the field, and then technology actually made this happen.
Yeah. And we also have to step back and realize, I mean, because again, we're very all of us in here are very technology centric, and we've worked at companies that are pretty progressive technologically. Like, never forget, there are still operators out there that are doing everything in Excel still. Like, they don't even touch Spotfire, like, and that's a 10-year-old deal in oil and gas. I mean, there's so many slow, people that are still slow to adopt. I mean, you're going to have your BPs and Conocos and, whoever else like pushing the envelope, right? Because it's incumbent on them, and they have the money to throw at it. But
but you need to, like you say, they have some people is a slow adapter. Some people is open mind.
Yeah.
You need to consider that one. It's not everybody has the same mind, right? Some people say, "Oh, I'm doing this for 30 years.
Yeah.
I really don't want to change. I'm happy with this.
Yeah.
If I don't do that every day, I feel not good."
Yeah.
Do something. So, but anyway, it's like I see that technology is good. Like there was when I was in China, when I was a young boy, I see the TV had the advertisement say technology made life better. Is that?
Yeah. No, I mean that's it's gonna be interesting moving forward to see because of all the doom and gloom with AI
implications
becoming sentient and all of that fun stuff, which I still think we're pretty far off of that. But if you've ever used even just like the agents right now, like I've done quite a bit of messing around with them, and sometimes a guided agent can actually get you pretty far, but it still needs
a lot of
I equate it to bowling with bumpers, right? Like you pull the bumpers up for the kids so they don't go in the gutter. It's the same thing with the AI bots now, right? They're very young. They're still figuring things out. And those bumpers are the human guiding it and forcing it back so it doesn't go off on these
off the rails,
crazy
literally.
The crazy stuff. Like the Terminator. My favorite movie is Terminator.
Wasn't there something
especially Terminator 2.
Wasn't there something like an Air Force AI thing? Like it kind of went off because like it was told to like attack, and then when the people that were telling it to back off, like it went to go attack that, like they were doing some testing, and like it was AI, and like it saw them as a threat because it was telling it to stand down, like, and they didn't consider those implications of how it was trained, and then it was trying to attack them because they were the ones telling it to stop, and it saw that as a threat. Like
we had the I think it was Deloitte brought their little Boston Dynamics dog to our show a couple of weeks ago, and it was watching it walk around. I was like, this is so awesome, but this is also the most terrifying thing in the world because it's like you could imagine a battlefield of 1,000 of these things with guns on their backs and rockets and all kinds of shit.
Looks like Star Wars.
And it literally looks like Clone Wars where there's just robots fighting each other, and you're like, that's a very real potential thing in the future, right?
It's going to happen, buddy.
It's terrifying.
This is a foundation model.
Yeah,
you can ask it to do anything right now. It's like,
it's gonna be fun, and hopefully mostly more fun than scary. But we've blown through this hour, but I knew it would be good because you've got such cool experience, and
it's good to come here.
Yeah, appreciate it. We'll we wrap up with some just quick fire questions. Just give us just random stuff. Just give us kind of a short answer. The first one I'll ask you is Azure, AWS, or GCP. Which one is your favorite?
I never play with the AWS, but I think if the next one I had a choice to choose, I will use AWS.
Yeah.
I never use it.
It's funny because I've never used GCP, but I've heard good things. But maybe it's like the grass is always greener.
GCP, I'm not sure right now. I use it in Anadarko. Sometimes they are not that updated. Let me give you an example.
Yeah.
At that time, GCP, like the stream processing, GCP had a data flow or data frog, something like that. It's similar to the StreamBase or like the Kafka. But at that time, when they say at 27, they say, we asked them, are they support Python? They say, yeah, we support Python too.
Oh.
That's one example. Another example, that's 5 years ago. Not right now. 5 years ago, we built ML model. We want to use they call it a ML engine.
Yeah.
In the cloud. I'm not sure right now called AI
Vertex
platform, something like that.
Yeah.
They changed the name. And we want to use a TensorFlow. At that time, the TensorFlow is 21 or something like that. But there wasn't in there. It's like 9 or 10.
Okay, yeah, what they supported. And those are very different too, because I think even when I was doing that whole TensorFlow, like the model I was talking about earlier, it was right at the time where I think they switched from maybe like, one version to another. So like I had to specify the version that it was using because it would totally break.
Because like me, we always try to test the latest open source model.
Yeah.
And if like that's too old, we cannot deploy it. Do you see what I'm saying? That's why at the time my VP Anadarko at the time said, "Ding, let's use the cloud ML engine."
Sure.
Because we signed a deal with them and we need to use the credit. But I said I cannot use it because it's too old.
Yeah.
And then people doesn't understand why the TensorFlow is from Google. Why it's so old? But you need to understand it's from Google brand or Google AI. It's not from Google Cloud.
Yeah.
It's a different company.
Yeah.
It's although they all under Google. So I'm not bad mouth about Google.
No. I think that's a very common.
No, I mean AWS is it's the gold standard.
It's a common.
If we're being honest, I mean, like it is what it is.
And also after that, they release a news saying not going to do any the AI stuff for the oil and gas. Come on, buddy, you guys are failure in the oil and gas.
And then 4 months later, we're gonna do something with the Ramco.
Yeah, they back out of that.
Yeah,
and
it's 2020. At that time, the whole company is discussing this news and ask me, Ding, are they doing good stuff for us? I say, 0.
Yeah.
That's funny.
It's very true. I think they really shot themselves in the foot with our industry because of that. But it's also a very common misconception that it's like, oh, well, it's AWS. It's like, well, AWS has a million departments because there's a million different tools there, and all of them do, right? I was going to ask you what's a really good book that you would recommend for someone either getting into data science or energy or just in general?
Not a book, but I know that Andrew Wu, that's the Stanford professor before. He
Stanford?
had Andrew Wu, NG. Andrew NG.
That's how do you say it? Okay.
In Chinese, it's Andrew Wu Andrew, but that's a Chinese. But his class, like in the Coursera, they call it the ML specification, or they had a series, one series is called the ML or like the AI, but they have 4 courses there. That's the best course I see, explaining the neural network, the machine learning is the best course. That is the good one. I always recommend the people.
Yeah.
We can put in the link in the comment that one.
But
that is actually the best course I see in my
He's
career.
the gold standard, with all that kind of, those courses are really good.
Yeah, Coursera. He's the founder of the Coursera. So he actually is the big guy in the AI side. He used to be a professor in Stanford, but he came out and found a lot of company. But he explained that one very easily, like linear algebra, because all the back end is linear algebra.
Yeah, that's what it is. Yeah.
So that's the good course. Trust me, that one.
Yeah, he's got a really good course. I watched it recently, right when all the LLM stuff was coming out. But it was he had one on like prompt engineering.
Yeah, that one is also a good one.
Yeah. So
you want to wrap us up?
Yeah, just one more. What's the favorite open source model or favorite open source package rather? Sorry, or Pandas, yeah.
Yeah, that's the Pandas we use every single day.
Have you messed around with polars yet?
No.
What's this will be the last one and we'll wrap up. What's one piece of advice you give to someone either trying to get into energy and data specifically? So assume they're a college student coming out of school and they're interested in getting into being a
data
scientist, a data science advisor at some point. What advice would you give them?
Yeah, I still back to the original advisor. It's just like find the use case.
Mm-hmm.
Yeah.
And so is deliver the use case.
Yeah.
Use any method you see fit. No overkill, no underkill.
Yeah.
That's it. Yeah, that's the secret. I get survived by several rounds of the layoff.
Yeah, 100%. I mean, like I came into Conoco, didn't know anything, but you make yourself useful and you solve people's problems, and they're happy. Like
that's very true.
That's the best one. And because in my short career, like 10 years in oil and gas, I experienced more than 10 rounds of layoff and also too much. I survived. So that's the way you need to do.
Yeah.
Just find the use case to solve somebody's problem. Use the most appropriate technology.
Yeah.
Not overkill, not underkill.
Yeah, 100%.
That's great advice. Ding, thanks so much for coming, man.
Thank you.
Yeah, thank you.
Great talk.
We'll end it on there.
Yes.
Yeah, thanks,
Yep.
man.
Yep.
We'll have you back. Thanks, everybody.